Good afternoon, everyone. I am Sarah Phillips, the director over here at the Kodiak Chamber of Commerce. I want to welcome everyone to the Mariculture How Do I Get Started webinar here, part of Alaska Startup Week 2020. Thanks so much to everyone for joining us. We're going to get started here in just a moment. I'd like to remind everyone, please utilize the chat function, ask questions, make sure that you're interacting with the panelists. That's why we do these sessions live and not pre-recorded, so that you do have the opportunity to interact. Again, as a reminder, we are also streaming this live to Facebook right now, and we will be recording this presentation to be used in the future as just a recorded version for anyone interested. So if you do happen to have a video on or use your voice, you may be recorded, and I just want you to be aware. But in this webinar setting, that chat function and asking questions is really a great way to interact. So we're going to go ahead and get started with the Mariculture How Can I Get Started presentation. Today joining us, we have Tamsin Peoples, a mariculture biologist and mariculture advisor, and Riley Smith, an Alaska Fisheries Development Foundation. And so Tamsin is a lifelong Alaskan. Tamsin fell in love with the ocean at a young age. Her childhood dream of becoming a marine biologist was fulfilled by graduating from the University of California, Santa Cruz. While obtaining her bachelor's degree, she spent hours underwater in the kelp forests of Monterey Bay, observing and studying the complex ecosystems that algae creates. After graduating, she returned to Alaska, working various contracts with NOAA before working with Dr. Michael Steckel. I'm sure I just said that wrong, Tamsin, you'll have to correct it. At the University of Alaska Southeast, conducting a seaweed mariculture feasibility study for blue evolution. With the methods set, she designed, built, and operated North America's largest commercial seaweed hatcheries for blue evolution, first in Juneau and then in Kodiak. Tamsin now works with Dr. Steckel on increasing the productivity of Alaskan kelp mariculture and advises individuals and small communities on entering the mariculture industry. Riley Smith is the development director. I believe that's what I'm seeing. Since its creation in 1978, the Alaska Fisheries Development Foundation has been dedicated to identifying opportunities common to the Alaska seafood industry and developing efficient, sustainable outcomes that provide benefits to the economy, environment, and communities. In 2014, AFDF began spearheading the Alaska Mariculture Initiative, a strategy to accelerate the development of mariculture in Alaska. Smith graduated from University of Washington with a bachelor's degree in environmental studies, environmental science, and resource management. At AFDF, Smith works on research related to social responsibility, environmental sustainability certification, mariculture, outreach and communications, grant procurement, and grant management. Smith works closely with the Mariculture Task Force on the implementation of the Alaska Mariculture Development Plan with a goal to grow 100 million industry in 20 years. So please join me in welcoming both Tamsin and Riley. Thanks for being here.
Thank you, Sarah. Happy to be here. Tamsin's going to share a PowerPoint, and I will lead off and then transfer over to Tamsin for the rest of the presentation.
All right, is it up and running?
It is up and running. One moment here. Okay, yeah, thank you for having us. So Riley Smith here with Alaska Fisheries Development Foundation and Tamsin Peoples of Coral and Kelp. Tamsin's also a lead contractor in one of our grants, which we'll be speaking to today with USDA. Next slide, please. So I'll be talking about progress in the industry, opportunities for mariculture, entrepreneurs, and next steps. And then we'll transfer it over to Tamsin later. Next slide, please. So to begin with, what is mariculture in Alaska? Importantly, it does not involve finfish farming, as it is prohibited under Alaska Statute 16.40.210. Next slide, please. However, mariculture is the enhancement, restoration, and farming of shellfish and seaweeds. Species include oysters, clams, mussels, geoduck, crab, sea cucumber, and seaweeds or kelp. Alaska oyster farmers are primarily focusing on Pacific oysters. Alaska seaweed farmers are currently focusing on sugar, ribbon, and bull kelp. Mariculture has a host of benefits to Alaskans. One is economic. It provides jobs and commerce in coastal communities. Two, environmental, improves the local ecosystem in various ways, such as habitat improvement, carbon removal, or countering ocean acidification. Cultural, it's compatible with traditions, cultures, and skills in rural communities. Industrial, it complements and expands our existing renewable seafood industry, which is Alaska's largest private sector employer. And food security, increases access to local foods for all Alaskans. Next slide, please. As Sarah mentioned, in 2014, AFDF began spearheading the Alaska Mariculture Initiative, which is a strategy to accelerate the development of mariculture in Alaska. The initiative led to the establishment of Alaska Mariculture Task Force by Administrative Orders 280 and 297 under Governor Walker, and the adoption of a statewide comprehensive plan called the Alaska Mariculture Development Plan. The task force was maintained by Governor Dunleavy, which is now working closely with the Governor's Alaska Development Team towards priorities identified in the plan. Next slide, please. So the task force consists of 11 members, with 1 member from each of the Alaska Department of Commerce, Department of Fish and Game, University of Alaska, Alaska Sea Grant, and 7 representatives from an inclusive group of stakeholders in Alaska. The task force also includes ex officio members from the DEC, DNR, and NOAA. Next slide, please. The plan, which was created out of the Alaska Mariculture Initiative, is to grow a $100 million mariculture industry in 20 years, with dozens of near-term and long-term recommendations, research priorities, and goals. An important goal of the task force is to implement priority recommendations of the plan. The task force is designed to sunset in 2021. Current priorities of the task force include the formation of the Alaska Mariculture Alliance, which will supersede the task force, and the creation of the Mariculture Research and Training Center, which will coordinate industry needs with researchers, universities, tribes, municipalities, government agencies, and more, in an effort to identify key research, including funding opportunities and an annual R&D forum. The task force is also working to pass CSHB 41, which includes shellfish enhancement, ASME marketing of mariculture species, and increased coordination across stakeholders. Next slide, please. So there are many innovative kelp products in the market and in development for human consumption today, especially in Alaska, many of which are value-added substitution products. For instance, we have Barnacle Foods, who has a wonderful kelp salsa and bullet hot sauce. Blue Evolution has dried Alaska kombu, seaweed pasta, and much more. Seaweed is also used in raw material markets for livestock feed supplements, medicine, cosmetics, i.e. skincare, and fertilizer. Currently, the 2 major buyers of seafood in Alaska are Blue Evolution out of Kodiak and Barnacle Foods out of Juneau. Next slide, please. Interestingly, seaweed has also emerged as a potential bioplastic. So upper left, you have Glenlivet edible whiskey pods with a casing made from seaweed. And the right features Oceanium's nutraceuticals made from seaweed as well. In fact, Oceanium, which is a UK-based company focused on developing eco-friendly bioplastics from seaweed, has shown immense interest in Alaska's developing mariculture industry. Next slide, please. As you can tell, AFDF is very involved in the mariculture industry, and we have a host of mariculture projects outlined in this slide. This is just the tip of the iceberg for public and private investment. Some important ones do include a domestic and European seaweed market assessment for Alaska marketing communication strategy for seaweed, seaweed product development, training and technical assistance to interested mariculture entrepreneurs, and increasing hatchery capacity and technology development to secure oyster seed supply in Alaska, developing the Mariculture Map, which Tamsin will speak to later as a GIS mapping tool of coastal Alaska, development of scalable and coastal offshore seaweed farming, assessment of seaweed processing techniques and equipment available in Alaska, and seaweed quality handling guidelines. Next slide, please. The number of aquatic farm lease applications are a tangible indicator of growth for the mariculture industry. There has been a significant increase in applications received from the state for aquatic farms, hatcheries, and nurseries in the period from 2017 to 2020. For example, in 2016, the state received only 4 applications. In 2017, 2018, 2019, and 2020, the state received 16, 17, 14, and 17 applications respectively, for a total in 4 years of 64. In terms of sales, in 2019, there were over 1.75 million oysters sold. In 2017, there was only 18,000 pounds of seaweed sold, 89,000 pounds sold in 2018, and 112,000 pounds sold in 2019. 2020 expects to see roughly 200 to 300 pounds sold. There are needs for the industry though. In order for Alaska's seaweed farming industry to grow, sales of Alaska seaweed must increase. Hence, these increased sales of Alaska seaweed must also necessitate increasing the number of companies purchasing and processing seaweed, including bringing in new companies to Alaska and growing the capacity and capabilities of established processing facilities to increase the amount of seaweed processed. Much of these business decisions hinge on an understanding of prices, production and equipment costs, and profitability, which allow for decisions regarding product and market development. Companies currently buying Alaska seaweed and companies considering entering this business have expressed the need for more information on in-depth market analysis and assessment, marketing communication strategies, product development, optimal processing equipment, nutrient and contaminant profiling, processing technique information, and much more. The good news, though, is that there has been immense private and public investment in addressing these bottlenecks to industry growth. Alaska mariculture industry is young, valued at just over 1.5 million in annual sales, however, is poised for immense growth and has proven potential, especially with Alaska's vast coastline, nutrient-rich waters, and existing capital. So Tamsen Peoples is a primary contractor on our USDA grant, spawning mariculture business in Southwest Alaska in partnership with Apicta and Swampsea. Next, she will speak to the kelp farming cycle and in addition, our USDA grant project, including resources and technical assistance available to interested farmers in Southwest Alaska. Thank you so much for your time. Tamsen, you're up.
Great. Thank you so much, Riley, for your quick overview. So you got someone coming up with a question. Oh, just another message from Sarah Phillips. All right. So I'm going to go over briefly what is the difference between mariculture versus harvest. Wild harvest of seaweed has been taking place around the world since time immemorial by indigenous peoples, and it continues now even into the modern economy. Harvest can take place on the intertidal. So these are some folks in Ireland, on coastal Ireland, collecting seaweed at low tide, or it can be done from the surface of a boat. If you're harvesting bulk kelp or giant kelp, any buoyant species, you can just harvest it from the top of the water. It makes it a little easier, tidal independent. In some parts of Southeast Asia, they do a wild harvest of this green type of seaweed in relatively shallow lagoons. And they harvest it by basically taking these big pronged tridents, sticking it down into the seaweed and spinning it around like you would spin your fork in your spaghetti, pulling it up onto these shallow boats, and then moving back into an area to deposit their harvest. In contrast to wild harvest, mariculture is the specific growth of seaweed for human use. Oftentimes it's grown on long lines. So on the left here, we have a picture of sugar kelp being grown on the East Coast. And on the right is a picture of pyropia or porphyra being grown on a netting that'll be grown in the intertidal zone. And though it may not look like it, that red seaweed growing on that netting there is the same sushi seaweed that you get wrapped around your sushi or on your little seaweed snacks. That's starts red and then you roast it, it turns that nice deep emerald green. These mariculture operations can be absolutely massive. These are some plots of those nets of that sushi seaweed being grown off the coast of Korea. Each one of these kind of sectioned areas might be tended by 1 or 2 farmers as a co-op. And you can see just how sprawling these farm systems can be. This is a satellite image of that same area. As you can see, all those little squares are the pyropia porphyra nets that are sitting in the intertidal zones. Another type of mariculture is onshore mariculture. So this involves growing seaweed on land, but still using seawater. So on the left, we have these big drums or tubs filled with ulva or sea lettuce, that bright green seaweed that we get in the intertidal zone here. Ulva can grow by fragmentation. So if you break 2 pieces apart, those 2 pieces will continue to grow just vegetatively. And so we have these big tanks being bubbled with air, not so much to keep the oxygen level high in the water, but just to keep them moving, get them even exposure to the sunlight, and to help encourage that fragmentation. On the right, those bags of green, goopy looking material is growing very small phytoplankton for oyster feed or other mollusks. But if you've ever had spirulina additives into your smoothies or spirulina extract pills, spirulina is grown in the same way and can be grown onshore in that same methodology. One of the big questions I always get when I start talking about seaweed is what the difference is between an algae, a seaweed, and a kelp. The biggest distinction, or the most total unifying term, is algae. And an algae is any non-vascular photosynthetic organism. So non-vascular means that it doesn't have any sort of system inside of it to transport material. Like we have our blood vessels, we have our veins, and a tree has its sap, its xylem and phloem. Algae doesn't have that. And algae can be either freshwater or marine. So seaweed are just the big marine algae that we can see with our naked eye. And there are three major classifications of seaweed in the ocean. There are your green seaweeds, your red seaweeds, and then your big brown ones. And kelp is a kind of vernacular term for just big brown seaweed. So this should be a fairly common image or fairly common occurrence to see on your beach getting washed up. And anyone who spends a lot of time with their boat in the water knows exactly how big those big brown kelps can be wrapped around your propeller. Here's a basic diagram of what a kelp looks like. This is a ribbon kelp, Alaria marginata. So I'll be using a couple different terms throughout the talk. And if you ever hear about researchers or individuals referring to it, the blade of the kelp is the photosynthetic part. That's kind of analogous to the leaf. That's where that organism is producing photosynthesis, producing the energy, converting sunlight into food. It's often very smooth, more translucent, sometimes a little bit more leathery, but it's usually a pretty broad surface area. Some types of seaweeds, like this ribbon kelp, have a midrib, which is a more thicker, leathery, starchier part that runs down the length of the plant. Some of them don't have them, but for those that you do, it looks like basically a vertical stripe. A stipe is the bottom of a big kelp. You can think of it analogous to being the stem or the trunk. So on the bull kelp, it's that long, narrow kind of whip part to the kelp. Stipes can be a matter of centimeters, or they can be up to 100 feet long on the bull kelp. Underneath that stipe is the holdfast, and this is where the seaweed connects itself to whatever substrate or bottom it's growing on top of. It can look like a root structure, like you see in this picture of the alaria or the ribbon kelp, but it doesn't actually participate in any nutrient uptake. It just is an anchoring system. And a lot of these seaweeds, especially those that live in the high surf zones, secrete a natural cementing compound that can really help them hold on in some pretty intense conditions. Some types of seaweed, like this ribbon kelp, produce sporophylls, which can kind of look like these big kind of almost grape clusters on the bottom. This is where they produce their reproductive material, so you won't always see them, but when you do, that's where they're going to be growing their vegetative sorus. Other seaweeds might just have kind of a source just growing on their big blade or their big smooth parts, like a bull kelp does. Riley mentioned a couple of different types of seaweeds being grown in Alaska commercially, and these are kind of the big three stars that we have right now. On the left, we have that ribbon kelp or alaria. In the middle is our saccharina or sugar kelp. And on the right is our Nereocystis or our bull kelp. The operations in Kodiak are currently only growing alaria and saccharina, while operations down in Southeast Alaska are growing bull kelp as well as alaria and saccharina. There's a number of species that are being wildly harvested for smaller cottage style industries or in Barnacle's case, some larger commercial operations. On the left, we have Palmaria, which if you're familiar with French cuisine is also known as dulce. Palmaria has now changed its name because everyone's rewriting all the species due to genetic research. And then the middle there is Pyropia. That's that red seaweed that was growing on the nets. That's your sushi seaweed. The native Alaskans down in Southeast Alaska harvest two different types of Pyropia, and they call it vernacularly as blackweed. Bull kelp, again, is being harvested by a couple different groups throughout the state for doing small cottage scale industries for salsas, pickles, and relishes. There's some small operations that were doing fucus or popweed or rockweed. They were just harvesting it and drying these little floats and making like little rockweed poppers, kind of like a snack food. And there's a number of other potentially viable species that are endemic or local to just Alaska that have not quite been explored yet for their viability. Dragon kelp, this picture here on the left, is an absolutely huge, huge kelp plant. Imagine you took a ribbon kelp and then made it big like a giant kelp. It has a very similar lifestyle and reproductive style to the other kelps that are commercially grown now. And I spoke with Matt and Leah of Barnacle Foods, and they did get a chance to experiment with it, making a salsa. And they said the flavor was great, but the alginate was so heavy in the Eularia or the dragon kelp that their salsa turned into just a jello or a gelatin. So potentially as an extract or looking for an alginate source, dragon kelp might be a fantastic commercial species. We also have a different type of sargassum, which is the middle image. In Japan, they have a type of sargassum they grow there in pickle, and that's referred to as hijiki in Japanese cuisine. We also have the ulva and the ovaria, those two on the side there. They look almost identical. The only way you can actually tell them apart by species is to do a cross section and see if it's 1 or 2 cells thick. Blue Evolution is currently growing ulva down in Mexico in these big onshore grow facilities, and they're using that to mill into powder for their pasta and popcorn products. We also have a huge amount of laminaria or kombu style genuses and species here in Southeast and the rest of Alaska, a number of which have not yet been identified as being analogous to Japanese kombu, but in the same family and genus. So if you ever want to know anything about seaweed or you need help getting to identify seaweeds, the most comprehensive collection of seaweed material right now is seaweedsofalaska.com. They also have a book that was published by the same group. And this is the best way you can go. If you have a mobile device and you're out there on the beach, you can just pull those up. Or if you have the book, it's basically the only comprehensive Alaskan specific seaweed guide. And again, on the right or the left here, you can see we've got the chlorophyta, the ochrophyta, and the rhodophyta. So general rule of thumb, if you see a green seaweed, click on the green seaweed button. Brown seaweed, click on the brown seaweed button, and red for red. So the kelp mariculture process that we are utilizing right now in the state of Alaska was really first developed and implemented commercially in Asia. And then within the past couple of decades, folks on the East Coast started implementing it and utilizing more American-specific materials. And when I started working with Dr. Steckel back in 2015, we tried to duplicate that process, but again, making it a little bit more Alaska-specific. And this whole process is based on the wild natural life cycle of these big brown kelps. So the life cycle of a kelp is relatively straightforward compared to some of the other seaweeds. Here's an imaginary seaweed plant. We've got this big blade. Again, that's where all the photosynthesis is happening. And at one point of the year, you're either going to have a sporophyll, that little grape cluster on the right, or a sorus come in the middle there. And those are going to create that vegetative or fertile material. And usually around late summer, early fall, those sorus or sporophylls release these spores. And these are single-celled little guys that are swimming around. They're motile, so they're swimming through the water current or water column for anywhere from 6 to 36 hours. Eventually, they run out of energy, stop, and settle. And whatever they settle on, that's it. They are stuck there. So hopefully, it's a good substrate or a good substance in a good location. They're going to germinate into these little gametophytes, either male or female. And these are still really tiny. These are only 5 to 20 cells long, microscopic. They'll become fertile and they will fertilize and mature each other. Again, the male will release another type of spore, which will fertilize the female egg. And that will create a tiny, teeny, tiny recruit. And under the microscope, this will look like a tiny little blade. I mean, you can count the cells across, but that little blade will continue to grow and continue to grow into this juvenile and continue to grow into these big, massive plants. So we're utilizing this natural wild life cycle, and it starts by going out and collecting the fertile plants. And how you do that is just basically going out. Once you know what you're looking for, it's pretty easy to determine if a plant is fertile or becoming fertile just visually. It helps if you can convince your friends that it's really fun to go lie face down in the intertidal zone and find plants. And then you're going to collect those fertile pieces and bring them back to your lab or your hatchery. And here's some really good pictures of what that fertile material looks like. When you got a really good fertile sori, so on the left, we have a piece of bull kelp, and those kind of Nutella spread looking patches, that's that reproductive material. That's what you want to bring back to the lab or the hatchery. You don't have to bring the whole big bull kelp plant. You can just cut those little Nutella patches out. We bring those back to the lab and we stress them out to get them spores. We're going to dry them out, clean them, make sure that there's not any other tiny little organisms hitching a ride in, like any other plankton or little invertebrates. And then we're going to put them in the fridge overnight. And that's basically stressing them out to make them think that, oh no, it is coming on to fall. I better release all my spores or I'm never going to reproduce again. So when we put them back into clean seawater, they'll release all those little swimming spores. You can see the water here kind of looks like puddle of muddy water. And under the microscope, hope this video will load, these little spores will be swimming around again for anywhere from 6 to 36 hours. They'll swim around. This is a really, really good release from bull kelp. All those little guys zipping around are each individual spores. After that time period, they're going to stop and settle onto, again, whatever substrate they stick to or stop swimming on. And we're hoping we can get them to stick onto string. We have this, any sort of polyester or synthetic twine works. It's almost like a kite string. There's a specific type of string used by, in the Asian industry, it's called kuremona string, which is developed. It's been really successful. It doesn't fray or fall apart if it starts to unwind. It's got nice texturing for those plants to grab onto. And so we wind this string around PVC piping just because it's cheap, readily available. We put that spore solution, so we drip those spores into a set volume of water, so we know how many spores per milliliter or liter of water there are. We put those pipes and that spore solution into the dark for about 24 hours, and this just encourages those little spores to stop swimming and settle down. And then once they're on those pipes, we incubate them, just like you put your seedlings onto a grow tray in a greenhouse. So our incubators are running on 12 hours of day, 12 hours of night, just full spectrum bulbs. Some hatcheries will adjust the intensity of the light to increase growth rates. Some hatcheries will use fertilizer just to give those plants, again, the extra oomph that they can get, trying to speed up their growth as much as possible. In about 6 to 8 weeks, you're gonna have these tiny little blades, all of these little orange brown dots there. Those are tiny, tiny little sugar kelp blades. And if you let them keep going, they're going to grow until they're pretty big. Once they start to grow, these guys go exponential. And we want to be outplanting them when they're pretty small, only 1 to 2 millimeters. This pipe on the right, while a nice visual, is a little bit too old to be outplanted. Just because at this point, those plants are so big, they're more likely to be knocked off when they're being transported and outplanted. And by outplanting, we refer to that meaning we're taking them from the hatchery, transporting them, and then deploying them onto the long lines at their outplanting or farm site. So this is how the outplanting works. The basic rule of thumb, this was a system that was developed back in the 70s for growing bull kelp. Again, we have that PVC pipe with our string wrapped around it, all those little plants on there. We thread the long line or grow line through that pipe, and then we're going to tie off one end of that string and basically unzip the length of that pipe, unwinding that string around the length of it. As long as your line can fit through that pipe, it can be any size line, any material. Generally, we say non-buoyant, doesn't have to be new line. And your farm array can be incredibly customizable. Every farm is going to be unique to every single farm site. These farm sites can be 1 to hundreds of acres long. Your grow lines or your long lines can be 100 feet or thousands of feet. It really depends on what the farmer wants to do, what the site is. Your anchoring system will be dependent upon what substrate you're in. Are you in soft mud? Are you in big bouldery gravel areas? How much scope do you need for that anchoring system? And really the only 2 requirements that we have or that you need to operate under this kind of seeding and hatchery system is the ability to readily and easily disconnect those grow lines to thread through those pipes, and to have those lines maintained a 6-foot underwater depth, so only 6 feet below the surface. So a lot of the farms these days are relying on a combination of tension and flotation and anchorage. So on this diagram, you can kind of see the blue lines here kind of bowed in the middle. It's called a catenary system. And next time you see a spider web, take a look at how the lines in the spider web are kind of bowed as well. That helps that tension maintain across a wider area. And there are marine engineers right now on the East Coast out of Woods Hole Institute and some private engineering firms that are spending millions of dollars researching on developing the perfect catenary system that's going to be unique for Alaskan waters. And then we also get a lot of questions about what's the cost of operating a site. And this is a kind of a bare bones, is what the bare minimum cost it would be to permit and seed a 10-acre site. So this is not including the expenses for your anchors, your lines, your buoys. But for folks in Alaska, it's pretty easy to get a hold of a lot of less than stellar or less than mint condition ropes or buoys that just wash up on the beach. You can do talk to local fishermen. If they have, you know, maybe they have their lines are just too short to deploy on a long line, but the line's still good. That's perfect access for you to grow your seaweed off of. The state of Alaska has a permitting system that goes by an annual lease, and it does have a scaling by acre. So the first acre is $450. Each additional acre is $125 a year. The processing fee after 3 acres, that's just for them to run through the application when you're applying for the farm site. The state also requires you to have a bond and insurance for your farm site. The guarantee bond is just, say, a big storm comes through and part of your farm gets broken up, entangled, washed up on shore. That's giving the state the ability and resource to go and help clean up that site or prevent further entanglement. And the insurance is just an operating insurance, just as any commercial fishing operation does. The seeded line, which would be grown in the hatchery and outplanted, the going price right now, kind of nationwide, the cheapest you can get is about 50 cents a foot, which is pretty expensive. A 10-acre site, if you have 20,000 feet of grow line, that means that right off the bat, you're going to be spending $10,000 on just seed. A number of operations strike a deal if they're doing a hatchery and buyback program, where they might allow you to take the cost of seed from the value at harvest at the end, or negotiate some sort of agreement on that front. As I mentioned earlier with the outplanting technique, here's a video from Ketchikan that first year. This is Trevor Sandy's site at Hump Island. It's a little bit jolting here, but you can see we're disconnecting that grow line. Each one of those big crab floats or A1 floats has a long line growing off of it. And we're holding onto the pipes as we're going to be backing down the length of this long line. That seeded string will again kind of flip off the pipes as we're moving around. The spacing is roughly 1 foot to 1 foot. So if you have 200 feet of grow line, you're going to need about 200 feet of seeded line. Right now, most of the hatcheries are operating where each pipe is holding anywhere from 200 to 250 feet of grow line. But depending on the hatchery and depending on the size of the operation, there'll be some shifting around and flexibility on that front. So once you get to the other end of that grow line, you're going to disconnect that long line, pull those pipes out, connect that seeded string on. Again, we recommend utilizing zip ties really frequently along the length of it, just to make sure that that seeded string is not going to shift or chafe along the grow line. Or, for example, if part of it breaks off due to stress, you're not going to have 200 feet of line or seeded string just bundle up in one rat's nest at the end. Outplanting is usually taking place right about now. We've seen that the optimal outplanting time period is around November through the end of December. If you have a big site like 25 acres, you're not going to be able to outplant it very quickly unless you've got a number of hands helping you out on your boats. When you outplant it, again, they're only 1 to 2 millimeters. These are pretty small blades. But after December 21st, after solstice and the daylight swings around, their growth picks up pretty rapidly. So this picture on the left, that would probably be, end of January, early February. This is what they'll look like in March. And then probably by May, you're going to get these plants that can be 6 to 10 feet in length on a good year. And again, this is all sugar kelp. There's a number of physical oceanography conditions that will affect the growth of your seaweed. A lot of these are going to be site specific. Seaweed's pretty flexible and pretty tolerant, especially these intertidal species like sugar kelp and ribbon kelp. Think about what they're going to have to deal with in the wild in the intertidal zone in the winter here. We've got little plants out there that are growing wild right now that are experiencing below freezing temperatures and snow and then sunshine and then underwater again. But general rule of thumb is the seaweed likes colder water and higher salinity. It's like the cold, clear water with less fresh water on top. So if you're going to be near like a glacier or a big freshwater runout, you're not going to have as good success as someone that might be a little bit farther away from that area. This graph here is from the research Dr. Steckel and I did in 2015, where we were outplanting seaweed at different times of the year to see when the maximum outplanting was and when the maximum growth rate was. And we were outplanting from October through March. And you can see there's a general trend that by mid-May, most of these plants had reached their peak. At a certain point, the seaweed will not be able to outcompete with other things that are growing on top of it. Seaweed grows like our hair. It grows from the bottom up. And just like our hair, the tips get raggedy after a while. Normally the seaweed's growing so fast that it's going to be able to outcompete that or replace the kind of split ends with new, fresher kelp. But after a certain time in the summer, that growth rate dies off and biofouling becomes a major concern on the farm for harvest. There's still a lot of research and development being done within the state of Alaska. There's a number of grants being applied for through Sea Grant, through NOAA, and through the university to further understand what conditions are optimal and how seaweed is affected by different oceanographic parameters, outplanting dates, what we can do to increase its growth, whether dropping it down to deeper depths to prevent biofouling at the spring. This graph is showing what dropper lines look like. So we had different lines deployed at different depths to show, if you had plants growing outplanted at the same time at 1 to 10 meters down, how did their growth change over time? And the case that maybe we did have an ability to drop plants down lower in the spring to have continuous harvest throughout the summer. The harvest usually happens in May. It really depends again on the year. Anyone who spends a lot of time on the water, especially the last couple seasons, knows that every year has been wildly different the past 4 to 5 summers. So keeping an eye on your seaweed is going to be critical. We always encourage folks to be able to go and check on their farms throughout the season, and especially as you're coming up towards harvest, working with your processor and your buyer to make sure that they're ready and that your kelp is ready before it starts getting biofouled with diatoms or other invertebrates growing on top of it. The harvest itself, in theory, can be pretty dang low tech. This is a time lapse, if it'll load, from that first season in Kodiak. There's Nick Mangini on the bow with Alf Pryor in the back, and I'm literally just sitting in the middle over fish totes with a little tiny handheld sickle, and we are by hand cutting off all the kelp. A couple of different groups have experimented with having these kind of line strippers, but general rule of thumb internationally is you just kind of whack it with a knife, whether it's automated or by hand. And then processing. You can keep, if the kelp is in a tote, an insulated fish tote with good, clean, fresh water, and it's kept cool, it can stay in that tote anywhere from 12 to 24 hours, upwards of 48 hours if it's nice and cool and good, clean water. That could allow for these big totes of seaweed to be transported from a remote site into town or to whatever processor you're going to. And processing seaweed is really going to be dependent on what the product is going to be. A lot of the industry so far in the state have been focusing on food-based products just because it's a really good cost value for the product. So if you're doing fertilizer, for example, you're not going to be getting as much per pound for the buying price. But talking with fertilizers, they also want the most biofouled, nasty, gross kelp you can give them because that's more nutrients and minerals coming out of the ocean. So in the picture here, we have ribbon kelp or Alaria served up 3 ways. We have the fresh, raw brown blade at the top. On the bottom, that bright, vibrant emerald color is a blanched Alaria. So just dipping it in hot water for just a few seconds will turn it into this beautiful color. And in the middle is dried Alaria. And if you're familiar with Japanese cuisine, this is wakame, or a similar type of species to wakame. So when you go to the Powerhouse, for example, and you get your miso, and those little pieces of seaweed floating around, that's wakame. There's a number of really great programs in the state of Alaska to encourage home-based food businesses or the cottage industries. Quentin Fong in Kodiak is a great resource for this. And so if you ever, a lot of these smaller organizations that are looking at food-based products started off doing this cottage style industry. For example, Barnacle started doing their first couple seasons of production in a shared commercial kitchen space area. It can be, as long as you, I think you have like 2 or 3 sinks and it's a, you're meeting certain standards, and depending on how your product is going to be served, whether it's frozen or pickled, it can be relatively easy to go into commercial production on a smaller scale. So I encourage you to reach out to Quentin Fong or look at the DEC home-based food business if that's something that's interesting you as a product. Some of the most common types of preserving seaweed internationally is drying, because it's pretty easy and it dries very rapidly. This picture on the left is the blackweed being dried in Southeast Alaska. The most common way, and it's been a tried and true method, is just putting it out in the sun on a bed sheet or on your living room floor with a bed sheet, and making sure that you're turning it over to make sure it's completely dried. Different families have different, techniques and recipes for, putting gumbo, chitin, or clam juice on them before you dry them. But just putting them on a bed sheet and make sure they dried enough so they're not going to become moldy is the only thing that they do for preservation. And on the right, those 2 images are commercial kombu drying in Japan. So we have the top, they're just hanging them drip dry from a rack system underneath a shed roof. And that bottom picture is how they do really high quality kombu. They put it out on gravel beds. And that'd be great here in Alaska if we could guarantee we're going to have enough sunny days back to back. We could actually dry out those plants on big gravel beds like that. But you think about if you had a Quonset hut or a greenhouse that wasn't being utilized that time of year, that seaweed does dry relatively quickly, especially with adequate airflow. Another most common method of preservation for the seaweed is either cooking, blanching, or pickling it. So in the middle, we have that seaweed salad. Again, if you go to the Powerhouse and get that seaweed salad, that's the wakame or that alaria. And then on the right, we have the Barnacle Foods kelp pickle. So that's getting it to a certain pH or acidity that prevents anything else from growing in there. The seaweed salads are generally blanched, seasoned, and then frozen in those big bags before they're shipped out. So it's kind of a lot of information we just threw at you, but if it's something that you've been thinking about and hopefully you're interested, which is why you're tuning into this presentation, the best place to start is determining whether or not you want to start with a wild harvest or go straight into mariculture. If you're thinking about developing a product, but you don't want to go all in on applying for a farm or going for, a 5 or 10 acre lease, you can talk to the state Alaska Division of ADF&G Fish and Game, and you can apply for what's called a commissioner's permit to allow for smaller wild harvest. It's going to be regional based, so some offices are going to be more willing or more cooperative than others. But Barnacle, for example, the first number of years that they were doing their production, they were going all off of wild harvest. So going out and just going to wild beds and collecting bulk kelp, hundreds of that or thousands of pounds of it. And as Riley mentioned, that the application process for the state can be time consuming. It might be a year or 2 before the application comes through. So developing a product through a commissioner's permit of that wild harvest could allow you to develop that product before your application is even approved. But if you want to become a kelp farmer, first step is to figure out where you're going to put your kelp farm. And just like any other real estate, it's about location, location, location. The big critical point for a lot of these farms, especially with the industry starting out now and a lot of these engineering and technical challenges of working in remote Alaska, is that you want to be able to access your site through the entire growth season. So that's going to be from November all the way through May. So think about all the big storms and blows you get going through the area. You want to make sure that you can get out to that relatively soon after a blow. So you don't want to be going out there once a month. You might need to be going out there once a week to make sure that there's nothing entangling in your lines, that there's not a whole bunch of drift kelp dragging on your buoys, that your anchors aren't being pulled around, that no one's accidentally hit your kelp site overnight. Another thing to think about is how far is it to processing? Again, are you doing a really fresh food product? then you'll need to have a tender be able to deliver it within 24 hours of harvest. Are you doing fertilizer? Well, you can slow boat that sludge. And then the big key factor is the access to wild beds of kelp. Currently, under the Department of Fish and Game regulations, commercial operations for hatchery are required to collect 50 wild parent plants from within 50 kilometers by water of where that farm is going to be. So not 50 kilometers by air, so you can't just draw a circle of the radius. You actually have to map it out by water. And if you're not able to find the type of seaweed you want to grow within that distance, you're kind of out of luck right now. For example, in Ketchikan, Trevor Sandy's site, he wanted to grow sugar kelp, but we were never able to locate sugar kelp within 50 kilometers by water of his farm. Currently, there's a number of different research projects going on within the university and NOAA to assess the viability of potentially adjusting those regulations and requirements. They'll have to do mainly off of genetic analysis, which is expensive, but NOAA is definitely on board to assist. And then another big site factor, as folks are very familiar with, is that the weather can be quite intense in the winters here. You don't want to be putting your farm site somewhere that's just going to get hammered by prevailing winds. Not only because you're worried about your buoys getting tossed around, your ankles getting dragged, anchors being dragged, but just think about all of the material that's going to get blown onto your site. So if you're looking around the area and you see a beautiful, nice big beach with all this driftwood on top of it, probably don't want to put your farm on front of that because all that driftwood had to get there somewhere. And if you have your farm there in the winter during all the big winter storms, all of that wood's going to get blown through over your farm and could potentially cause some pretty serious entanglement issues. So why is working with Kodiak, or why is growing kelp in Kodiak and in Alaska such a beneficial thing? Well, Riley mentioned the clean nutrient waters, the abundance of coastline that we have here. Kodiak's got that great fleet that's just for the most time in the winter is just sitting snug in its harbor. It's that perfect off season between salmon fishing and processing. Not a lot going on in the winter. When we do have a nice clear waters, you can see just how beautiful the water is and how rapidly the seaweed grows here. Blue Evolution and the number of farmers that are already operating in the Kodiak area have shown that it works well and that Kodiak is a great place to grow seaweed commercially. And the fact that we have all these amazing, fully experienced, clever and ingenuitive people and folks like you on board that want to pursue this, it's the perfect crock pot of possibility and opportunity to get this industry going. But if, as you're probably all well familiar with, there are a number of challenges with doing business in Alaska. It's expensive. It's also a new industry. But I can tell you, since I've been involved with this industry since 2015, we have made amazing advances in the willingness and helpfulness of the state. We have all these different agencies that are going out of their way to increase the resources, do all the research like AFDF and Sea Grant. There's a number of resources and assistance programs out there that can really help get this industry going. And we have the support of the state right now. So this is the best time to really get going. We've got a lot of momentum behind it right now. So part of that momentum and support is this grant that Riley and I are working on through USDA. Riley, would you like to cover it really quickly?
Sure, absolutely. Thank you, Tamsin. So the goal is to grow new mariculture business in Southwest Alaska through interested applicants and mariculture entrepreneurs in the Southwest Alaska region. Tamsin is the lead contractor here. As you can tell, she has a wealth of knowledge on the process. Next slide, please.
Yeah, where's my mouse? There it is.
So there's four pillars to this. Right now, we're of course doing outreach and public education. We are trying to solicit interested applicants to use Tamsin's wealth of knowledge, including assistance in the application process, which it is a unique process, and we're here to help. And included in that would be site plan identification and design and business plan tool development. Next slide, please. So like we noted, there'll be 6 individuals we're hoping to solicit to offer assistance in site plan development and business plan development, and hopefully with our free assistance for anyone interested. We will help 3 successful applicants go through the entire process. Next slide, please.
So the application process is probably one of the largest hurdles to get into this industry. I had someone mention on one of the questions on the chat already about the timeline for it. This image on the left here, this bizarre looking flow chart, is the steps that go through the application. It's a multi-agency application. So it starts with Fish and Game, then goes to DNR, then actually goes to the Army Corps of Engineers. When the first couple of years this was going, as interest was accruing, it was about a 2-year waiting period. This last year, DNR brought on 2 additional workers that are kind of working on processing the applications through, and now this application process can be taken care of within a single year. So you apply January 1st through April 30th, and then after April 30th, they start working through all those applications, and they've been able to award them within a single calendar year. So folks that are applying this past spring have already received their applications this year. One of the biggest steps, though, is a public comment period. DNR will alert or make a public notice and it's a month-long public comment period. So folks in the community, anyone who has upland rights to whatever property that water is, or their farm's going to be gone, will be notified. So far, for the most part, a lot of folks have been very supportive of especially smaller privately owned operations. As these operations start getting larger and larger, we're now getting applications for over 100 acres. Public comment is getting a little bit more concerned, but Fish and Game has been really good at facilitating that conversation between operators and applicants. And Riley mentioned earlier that part of the Mariculture Task Force was developing this Mariculture Map. So this is its beta stage right now. Feel free to go take a look at this website. If you can just jot that information down, or we can send the link to it later. This is a fantastic resource if you want to go start exploring an area, or if you have an idea about where you want to put your farm. This is a great service to go and look at all the different layers that they have there. So you're going to be looking at things like seabird colonies, marine animal haulouts. Is there seagrass? Is there herring spawn nearby? This allows applicants to readily access that information, which will be needed for the application. And speaking of what I can assist with on the applications, the biggest challenge are these maps. Fish and Game is and the application is very, very nitpicky on how they want their maps, with the legend boxes, the orientation, which exact charts, what information they want shown. From a number of applications I've assisted with so far, just getting these images set for the applicant has been a huge time saver for them. So I feel like I'm kind of an old hand at it now, touch wood, but this is a service I'm happy to and happily to provide for anyone who needs assistance through this USDA grant. And this is also including business planning. So working through the numbers of what it would cost to operate a farm from season to season, and kind of forecasting out 5 to 10 years, what the expenses versus income would be depending on pricing, as well as locating potential good sites near an area that you're interested in.
So in terms of, well, since we're running out of time a little bit here, I'll just quickly speak to this. So the Mariculture Revolving Loan Fund was created in 2012. It's managed through DCCED. And the goal of the program is to facilitate the development of mariculture in Alaska through loans for planning, construction, and operations of mariculture business. There's some metrics there on the side here, but the general requirements is you must have a permitted mariculture farm in Alaska, experience or training in the industry, be Alaska resident for 24 consecutive months. And cool things about the loan, it's from 100 per year with a maximum aggregate balance of 300,000. The interest rate will be fixed for the term of the loan. Loan term maximum loan term is 20 years, and loan payments may be deferred for up to the first 6 years. So this is a great resource for those interested in entering the industry.
So again, please do utilize our expertise and our training and this wonderful opportunity through the grant. If you're interested in working on an application, or just want to ask some more questions, want help with business planning or site planning for it, please do not hesitate to reach out to either or both of us for this great opportunity. Again, no cost to you, it's already covered. So we're looking for applicants who really want to pursue this. And at this, I guess if I can pull up the chat questions, I did see a number of questions that were posed earlier. We had from Commonwealth North for Riley, what's the turnaround time for a permit these days? Does ADF&G have a capacity to address increased volume of permits, and how many applicants are successful?
Yeah, thank you, Tamsin. So you did speak to this a little bit. It used to be, it's a joint agency application, so it's ADNR and ADF&G, and they both have committed more resources and staff to this process. And it was a 2-year waiting period, and it is down to within a year for successful applicants. A big portion of, or a big part of whether the application is successful or not is the quality of application. A lot of times it'll be back and forth between the agencies and the applicant, and responsiveness is crucial there.
And then the percent of successful applicants, I don't know the metric. Do you, Riley, have any idea what that ratio is?
I can say that there's 25 kelp farms that are under review right now, and there's 12 active mariculture farms across Alaska. 9 have been withdrawn, and again, it's that interactive process between the agencies and the applicant or what's going to determine the success rate. It's hard to really gauge that, though.
I had a question as well from Commonwealth North. Any dehydrated products on the market, and is it feasible? Dehydrated kelp is kind of one of the standard methods of kelp, especially coming in from Southeast Asia. It definitely is feasible. It's a great way to reduce the cost of shipping. The biggest challenge is securing an energy efficient way to dry kelp. So if you're going to be using big commercial ovens, again, it doesn't take a lot to dry the kelp to a standard that's food safe. So if you're able to harvest, maybe 1,000 pounds a day, dry it in a Quonset hut until it gets to a certain water content, bundle that up into a big package, and then ship it somewhere else for secondary packaging on a slow boat. That's one way that could potentially be a really comprehensive and attainable processing method. And then Jessica asked, what about exotics? Are we only allowed to grow local species? Yes, so Fish and Game has required us to only collect, again, endemic species from within 50 kilometers by water. That's, again, seaweed genetics right now is kind of up in the air, but working with the commercial hatcheries that are in operation, they know what type of seaweeds to be growing, what to look for. We don't have a lot of invasive species in Alaska right now, which is great compared to some other places in the world, but Fish and Game is going to do their best to keep it that way as well. So thank you once again. Here's our contact information. And unless there are any other further questions, I'll go ahead and stop sharing my screen.
Thanks, Tamsin.
Thanks so much, Tamsin, Riley. You guys did a great job. And I don't see any additional questions coming in, but naturally, any of you attendees today that would like to reach out, if you'd like a copy of this presentation, whatever it happens to be, you can reach out to chamberdirector@kodiak.org. You can obviously reach out to both Tamsin and Riley, whose information was on the screen there at the end. We're so happy that you guys were able to join us today. Again, this recording will be available on our YouTube channel. You can search all the Alaska Startup Week activities on our Facebook page, Kodiak Chamber of Commerce, and Alaska Startup Week Facebook page. So please, again, make the most of this whole week. We look forward to seeing everything that all of our amazing Alaskan entrepreneurs have come up with. And again, Tamsin, Riley, thank you so much for joining us today.
Thank you so much for having us. It's always a pleasure.